Welcome to Video 8. Building a stair gadget. Today, we will review writing a bill of materials to a file. Let's do a code review. Lots of little changes in today's video. Changes are marked with the blue flag, bookmarks, noted to the right of the line numbers. Our first change will be the version number. Has been upgraded to version 8. We have added one additional work point. This work point is used in the calculation of the stock required for the stringer. With the changes today, we needed for additional variables to be stored in the registry. Stock length, decimals, write bill material, and BOM write path. We will review each of these later in the code. These four were added both to the read and write registry function. As highlighted here, you can see where we are now creating a circle within the mark-a-point function. Because this is now a part of the mark-a-point action, I was able to remove all of the other calls to the draw circle function. Note the addition of the date function and that it requires one argument. The true-false argument will determine if the program returns a long or short date format string. As a good coding practice, I have included the date arguments as shown here. Additionally, I've added a helper function called getDistance. This function returns the distance between 2 points as a double data type. I've added three components to construct a bill of materials. These three functions, the header, line item, and the footer functions, construct two files at the user-defined location. Let's take a look at the header function. The first item is an if statement to determine if the user wants a bill of materials to be generated. If this is true, we construct a path and file strings for the files be created, issuing an open write command and then using the write file instruction. We issue a series of strings to be written to the header file. At the end, we issue a close file statement. And repeat the same function for the CSV/text file. As you can see, we repeat the same functionality in each of the files. In the LU button calculation function, we added additional capability to round the values to the user-desired decimal place. As you can see on line 410, the rounder function is being applied to the step run and step rise dialog values. Next on the list is rounder function. This function performs exactly what its name sounds like. Let's take a look at the main function, where you can see, not a lot of change has occurred except for some cleaning up and putting some error traps in place. One of the error traps is here on the inquiry box. I have added an if statement to determine if the user has pressed the OK or pressed the cancel button. Within the function of inquiry box, I have added capability to return true if OK and false if cancel was pressed. Before this error trip, the code would execute no matter if the user press cancel or press OK. Let's move on. I added calculation to the required stock length of the stair stringer. To do this, I needed to do some right angle calculation where I could get the opposite side of a triangle. On line 696, we are writing the header of the bill of materials. Proceeding on to drawing the stringer, and then adding the stringer to the bill of materials through the cut list file writer item. Moving down the code to 715, we issue a drain riser and the while loop where the treads are constructed. After the loop is completed, we issue another line item to the bill of materials, and one additional line for the treads. Then we close the materials actions with the footer function. Let's take a look at what changes were made to the dialog and bill of materials. I will try to place the screens so that you can see what's going on as I run the gadget. At this time, we do not have a bill of materials. Let me run the gadget. The dialog has changed a little. Let me start at the top and make some numeric changes to the stair structure. With 60 inches of rise, and 80 inches of run, and calculate. Adjust the tread count to 7 and validate the riser and tread amounts are acceptable. As you can see, a little bit of change in the layout was made to accommodate the BOM checkbox. The BOM checkbox indicates you want to generate a bill of materials. You can make adjustments to accommodate the stair configuration of your choice. This process is considered parametric drawing. The gadget will draw based on the criteria stair profile and now also provides files containing information about the components you have created. Notice the two files that have shown up in the directory. Let's take a look at the text file. This is a comma delimited file ready to be used within applications like Office Excel or other files that use delimited style formats. Let's take a quick look. Now, we should look at the Dat file. This is a file ready to be printed or cut and pasted into a solution of your choosing. As you can see here in the bill of materials, we have several data elements that represent the general information about the stair. Additionally, we have line items that represent the components to make up the stair. As a side note, we do not track the width of the stair and other data elements at this time. Therefore, we do not know the count of stringers, the thickness of the stringers, and/or the length of the treads and risers. Let's validate the math works with the dimensions. The diagonal matches exactly. Our tread matches, and if I can do this correctly, the riser matches perfectly. I count 7 steps and the bill material looks good. Let's take a quick peek at the additional work point I needed to add. Sometimes it's necessary to capture a work point while you're running a while loop instead of recalculating it from scratch. Any questions?